right, greetings everyone, and welcome to another exciting episode of IT Pro TV. I'm your host, Daniel Lowry, and in today's episode, we are continuing on with our Python programming series. Joining us back in the studio again today is our good friend and mentor in all that is Python, Mr. Justin Dennison. Well, Justin, welcome back to the show, sir. How are you doing today?
I'm doing great, Daniel. We started with Python the last episode, but we really need to dig deep, start seeing some more of those intricate ways that we can be more powerful. So that's what we're going to do today. But that power comes incrementally. We're more or less laying the foundation, digging the footers, laying the pipes, pouring the foundation, so we can write more meaningful, complex Python programs. So,
Yeah, well, we're looking forward to seeing that. In this episode, we've got some great stuff lined up for you. And you're right, we are trying to lay that foundation. We can't just throw you in the deep end and see if you can swim. That's not the best model for you guys to learn out there. So we did take a look at writing very, very simple programs, basically doing some simple math and some printing to the standard output of your terminal or whatever it is you're using. Now we need to dig a little deeper. We're going to see a little more of the power. And we're going to start with variables. And if you've ever worked with any kind of program before, you've probably heard that term. If you haven't, it's okay, because Justin, you're going to explain exactly what a variable is and how we use them.
Yeah, so variables allow us to, more or less, we get to store away, numbers, text. We got to store those away later, and it's very cumbersome to type that over and over and over again. You can very well do that. It's not a good practice, and it will make your programming experience more than frustrating. So I like to think of a variable as, when I create a variable, I'm getting a cup out of the cupboard, and I'm putting something in it for later. Then, oh yeah, I know this cup, it's labeled, it's mine, I know what's in it. And so when I need to come back and grab whatever it is, whether it's quarters or pennies or Cheetos, whatever it may be, then I'm like, they're in that cup, I know where to get them, and we're good to go. So something we have to worry about variables. Python allows us to define variables very easily, except there's some behind-the-scenes stuff that can make our life hard. There's these things called types. So a number is different than text, or there's other special types. And we'll get more into that later as we see down the line. But Python will allow us to change those, at our whim. This is very unlike some other languages such as Java, C, C++. So, we have to be careful. It can make your life hard. And we just, what's important there is using appropriate naming conventions, creating variable names that are meaningful to us, so we don't have to think about what does that variable represent again, and how is that represented by the Python interpreter, and what does that mean I can do with it, those type of things.
So Justin, when we have a variable, so we define some variables inside of our Python programmer that we're creating, what will we use them for typically? You said that they're a container, they hold things, but what typically are the kind of things that they'll end up holding?
So in Python, we start very much with numbers, which can be integers, which are whole numbers only, positive or negative, or floating point numbers, which have a decimal attached with them. We can also have these things called strings, which are their own entity and have all these things you can do with them, but you can just think of them as text between two quotes. And we'll see those in the future, what we can do with those things, as well as lists of things, and some weird other data types like dictionaries and tuples, and I just said a bunch of words that people were like, I don't know what you're saying. It's kind of scaring me.
Yeah, it's kind of scary, and it will be. We'll definitely get to that, guys. We won't leave you out in the weeds for too long with that stuff. But basically, what I'm hearing you say, Justin, is that a variable, like you said, is a box, or it's some sort of container, and inside of it is going to be some type of a value. It either is going to be a string, maybe a number, maybe a floating point number, plenty of different types of values. The cool thing about a variable is it will hold any type of value that we have available to us. And once you put that in the box, now I can easily reference that later on throughout my script. Because otherwise, if I had a long, because I've done this, don't do this, people. Don't create a long string or maybe a long path name. Now, this is a very good place where you'll see variables used. I have a super long path name. Well, I can continue to use that path name throughout my code and I will have finger cramps from typing it out over and over and over again. And what else happens is I'm most likely going to make a typing mistake. I'm going to have some sort of syntax error because I'm typing out this long string of stuff. And the more I do it, the more likely that is to happen. So I'll use a variable. This is what I do. This is how I typically like to use variables. I'll create a variable for that long string or for that long path name so that I can reference the variable instead of that path name. I'm a whole lot less likely to make a syntax error, and it's a whole lot easier to use. Makes my code easier to read as well.
Yeah, readability is very important, and it's funny that you bring up the path name because during my day-to-day programming experience, I have those all over the place. I'm like, okay, this is my documents, but instead of typing out, home / my username / documents, all these things, I'll just put that in a variable at the very top of my script, and it's always available to me. And I'll say like documents equals. But I think it's good to actually see how we go about defining variables and talk about some appropriate conventions that will make our lives easier, as well as your lives easier as well. So let's go ahead and take a look here. So I'm in a folder. I just called it variables just so we can, what are we doing? I think that's a good cue. I'm just going to open the interpreter. I always like to start in the Python interpreter, just quick prototyping type things, because it allows me to get immediate feedback. Like if I do something wrong, it's going to tell me that was wrong immediately, instead of, writing this giant program or script or whatever it may be, and having it break and me to start searching for bugs and errors and things like that. So how does Python ask us to declare variables? Well, in other languages we have keywords like var, or you have to talk about types first. But in Python we don't have to do that. I can easily say x equals 1. And I have defined my first variable. That's incredibly powerful. But there's some things behind the scenes that we have to take into account. First, x is now associated with a number type. So I actually have access to, just like the exit command was a function, I have access to this command called type. And type, if I do type and I read this, what is the type of x? And I type it, it'll say int. And okay, I need to treat that like a number because numbers behave differently than like a bunch of text. But anytime I type x, I get the value of 1, and I can say x plus 1, and it gives me 2. But notice x is not changed. But I can change variables. I can now say x equals, like crowbar or something. So if I type x, it is now the string crowbar, which again is just a series of letters and numbers. And if I use type, that'll say, hey, that's a type string. So that's something that we have to keep in mind, because that'll lead to some weird behavior that's hard to reason about. Now, I will say, Daniel, you saw me type x as the variable name. That is a horrible, horrible variable name. X. I wonder what that represents. But if I wanted something like my favorite tool, the standard convention is to use something called snake casing. And you will see this in Python. You actually saw me name my last script using snake casing. That means all lowercase letters, any compound of words are separated by underscores, and that's it. Can't have special characters like apostrophes. You can't have numbers. Can't start with a number. But you can't have, exclamation points, apostrophes, things like that, because those actually have other meaning in the Python language. So if I say my favorite, fruit equals banana, then I can say my favorite fruit. And now that's actually a single variable. That's a very descriptive variable that, I don't have to think about what's stored in that if I use them appropriately. Now, if I say my favorite fruit equals 7, then that is more of a problem. We should follow these conventions, they just make our lives easier.
Yeah, we were talking about conventions and standards before the show, and it just makes sense that if you're working on a program and you want other people to be able to help you with that, then using standard conventions is going to help them help you. And or if you're working with a team of developers one day and you create a block of code that you have always done it that way and it kind of deviates from how everybody else does it, think about how difficult that is going to be for them to be able to look at what you've done, interpret what's going on, and help maybe either find errors or increase efficiency. So using standardization, using conventions is going to be a big help. It doesn't mean that you never deviate from standards or conventions. You can always create a new standard or create a new convention. But for the most part, especially when working with other people, Justin and I both came to the agreement of it is the better policy is to use those standards, use those conventions. So for looking down the road, we're trying to be forward-looking in our programming so that other people can take a look at it and help us out with it. Well, now that we can define a variable, Justin, what do we do next?
Well, I think it's very important because Python has some weird nuances, like white space is important. So not having a space before a variable name versus having a space can actually break all kinds of things, as well as if we don't take into account those types, is it a string, which is, characters, is it a number, floating point number, then we'll get unexpected behavior. So I think it's important to look at the interpreter and just see some of these common errors that'll crop up, just so you know, hey, I've seen this before, I know what to do about this. And then, we'll jump into using variables with some, numbers and strings and just see some basic things. So when I'm typing, my favorite fruit, I'm going to go back to one letter variable names just to demonstrate these. So you aren't watching me type ridiculousness. But let's say I wanted y to be equal to 10. Except, unbeknownst to me, I accidentally hit a space. And I say y equals 10. And I get this weird error, indentation error. Now, in Python, the standard is you use 4 spaces to properly indent, and we'll see how indentation comes up. In these first programs, we're not going to have to worry about that. They're all going to be lined up along the left. But if I accidentally hit a space where I'm not supposed to, as soon as I start executing my script, it's going to break. And that can be very problematic. In addition to, now if y equals 10, okay, y is now equal to 10. But if I had y plus my favorite fruit, and I was like, oh yeah, I've stored the number 7 in my favorite fruit, and y, then I can get another error which says, hey, you can't put these two things together in the form that they're in. Like plus isn't meaningful with 1 plus the word the, or the word banana in this case. So we need to keep out with those 2 errors. Those are probably the first 2 errors that people will run into.
Very cool. And it's nice that Python has those helps built in to say, hey, you know what? You made a little bit of a syntax error there. You might go back, check that, see where the problem is. I'm going to help you out in figuring out what exactly the problem actually was. In this case, it was an indentation error, or you're trying to do mathematical computation on things that aren't mathematical. Words aren't math, right? They're just symbols that mean objects out in the real world. Whereas a 5 has some sort of extraneous meaning. It is a number. It means that. So you can't put those two things together. Python says, hey, let me help you out with that. You can't add banana and 10 together. It just doesn't work. You can go back, look in your code and go, what did I do here? See, look, I use these 2 variables. Well, maybe that's where the problem is. Maybe go back, use your type command, and figure out, hey, look at that. My favorite fruit is not an integer type. It is a string called banana. Let me go ahead and make that change to make it 7, and now I should be able to run my mathematical computation. Everything should work fine. All right, so what else can we do now that we understand how the errors can help us?
Well, I think it's good to see basic usage of variables, but as an executable Python program. And we did a little bit of that last show, but if we want to do systems admin or just automate some processes, there's a little bit more we need to do just to make our lives a little easier. So I think it's good to take a quick aside, and then we'll jump back right into variables. So I'm actually in this folder called variables, and I'm just going to make a file called variables. If you're on a Linux or Unix distribution, then this touch command just makes this file for you. So, and then I'm going to open it up in Atom. Now, if we take a look at this file, nothing in it, right? And let's just start with something like x equals 10, y equals 13, and then print x plus y. So I can do that. Whoa. Sorry about that.
Apparently that was an administrative level function that you're talking about.
Yeah. That is not the print function that was going on there. There were some updates that apparently I thought I'd run and didn't run. So there, got to be careful about those things. So if I print here, then what's going to happen? Well, if we switch back to our terminal, we can see that there, and I said last time, I can just, and there we go. Except it's real cumbersome to type that Python thing over and over again. In addition to, if I want to automate some things, typing that over and over and over again, that becomes probably like, how do I get things to automate when I have to type Python? Well, it's actually pretty easy. Again, on Linux, Unix distributions, if I just type which Python, I'll get what Python is my current interpreter. So I need to take note of this. So this user local bin Python. Sometimes there's interpreters also in the user bin environment folder or env folder. But if we come back, we can make a quick little change to our script, our Python file, and we're going to add a shebang. Now, are you familiar with shebang?
I have walked the shebang line quite a few times. It is, if you've done any, I've done bash scripting, so this is why I know this. Anytime you create a bash script, you have to start the first line always has to be the shebang, the pound sign and then the exclamation point. The pound sign is also referred to as the hash, so that's where you get the sh part of the shebang. Bang is the exclamation point. And then typically in a bash script, we put /bin/bash. So shebang, then /bin/bash, and lets you know where your bash interpreter is. I think I see where you're going with this, Justin.
Well, you might be pretty excited about this. I know when I first saw this, I was like, wow, that's handy. So you'll notice I took this which Python path, and again, this resides in various places. This is probably the easiest way to gain access to the Python interpreter that'll run things. And I did shebang, and then just type that path out. And notice it ends in Python. So effectively, this is running that Python portion to this script. Now, there's also one other thing that we need to do. Let's make sure that's saved. Common issue that I have is I'll forget to save changes in my file before running stuff, and I'm like, well, that didn't work out. So definitely be careful there. So I need to change these permissions just like I would on a bash script or any other executable script that I'm writing. And I can say chmod plus x, variables, and then this is, and you'll notice this changed in color. And you'll notice if I type LL or ls-LA, I'll get all of these permissions here. And I do have executable permissions now.
So it's a very important thing to remember is if your script isn't running, you try to run it using standard type of executable format in Unix or Linux type environments, and it doesn't run. It might be because it's not executable. You got to go in and set the execution bit. Using that chmod command is great for that. It's actually what it's for. So you can add that +X saying, I want to add executable permissions to my script so this thing will actually run. And a lot of great terminals like this one will show you that the color will change, indicating that that has happened. If not, you can run the ls-l or the ll command, and it will show you the RWX, which means read, write, and execute. If you see that X there, you should be good to go, and then you can use standard, regular command line interpretation to get this thing to run, right?
Yeah, so now that we've changed this to an executable file, I can actually /, is there a special name for that?
You know, I don't know.
I don't, you know, there's the
//
the shebang, // and then variables, and then I can run it just as a standard executable file. But where this becomes incredibly powerful is I can now, you know, set up automated cron jobs to run these scripts. I can have these just as something I click on, and, you know, if I set them up correctly, there's a little more to it. They'll run in Windows. I think this is kind of built in. This is assumed that you want these to be executable. You double click them, they'll run. But very, very handy. But now that we have this set up to be executable, let's get back to variables. So I have these few variables set up here, and in the shell, whenever I typed x plus y, I got the output always. Something to keep in mind, if you want to see output, like standard output, you have to have this print statement or something else that outputs to various other places. So if I come here, and let's just say I remove this, and I come and I run, it ran, and it looks like something's broke, but it's not actually broke. It just ran, loaded those variables into memory, and then it stopped, because that's what you told it to do. Programming languages are very literal, typically. Like what do you want me to do? Well, I want you to declare these couple of variables. Okay, then what? Then that's it, I guess. So
It's a great program.
yeah.
Hey, everybody write this at home. This is groundbreaking.
Yeah, this is change your life type of programming. But Daniel, I want to keep in mind that we're showing these kind of intro level things, because I like to think of these as, I'm putting tools in my toolbox. Right? I'm like, oh, okay, yeah, I got this hammer. I got this new screwdriver. I got this adjustable wrench. And then when we come to a problem, something we need to solve, we can always reach in and go, I got the perfect tool for that. So, as I said, it's kind of, you're like, oh, okay, I got you. You're just declaring variables. But this provides a lot of power in the future. So looking at these variables, I have x and y. What can I do? Well, I can print these as just standard, plus, minus, times, and divide, right? So if we go back and run that, then I have plus, minus, multiply, and divide.
So now we're actually getting some output that is starting to see where we might have some use to this. I can use Python to do math equations that I typically do on a regular basis. I always want to run and see, I can't think of any math equation. I don't do math. I'm horrible at math. But if I were to need that math equation every time, Python would be great for this. I would just have to plug in the variables and then give it the equation and let it do its thing.
Well, we might not want to do math, but we're getting ready to come up to something that may be of interest. We'll do some kind of hokey, fun things here. But it's important. Now with Atom, quick side note about Atom, if I hold Command Shift and hit D, well, I can just duplicate lines and then just change one thing. Way better than copy and paste. But there's also this other arithmetic, or this number operator. It's represented by a percent sign, and it's called the modulus operator. Now, what would I use this for? Well, let's go see. I got 10 and 13, right? So 10 plus 13 is 23, some negative numbers. Let's go back and run this, and you'll see these last two. This is divide. This is this modulus operator. When I divide, 13 will not go into 10 any whole numbers. So this is what's called integer arithmetic. It's important to realize that Python will do this, and version 3 treats this a little differently. There's some differences there, so you need to be careful. But this is a standard programming convention. This will actually give you what's left over after division. So this percent sign says take x, divide by y, and give me what's left over. It's a great way to essentially, like if I want to do every other thing, like if I want to go through a list of things and do every other one, I can use this and it'll skip to every other one. So you'll see that come up in some of the future scripts that we write. And then the final operator is x times y, and that's 10 to the 13th power, which should be a giant number, and it is. So handy operators.
And obviously, the order of operations is coming to play here. You had you have the x minus y. Well, that's really like you're going to get a negative number with that because of the larger. It's seeing it as a negative number, right?
Right. So, we look at these. You're like, that's great, Justin. You're showing me some simple math. I don't really understand why. Well, again, we're building to some stuff here. But you brought up order of operations when talking about math. Order of operations is not only a mathematical construction within Python, but we can enforce order in a variety of things, manipulating strings or lists of things. And we can do that just like we would in math by using parentheses. Now, I'm going to create a third variable that is a result of this complicated expression from the first two variables. Complicated, but so if I have a new variable z and x plus y times 7, right? So I now have two operators. This would follow the standard order of operations. I would multiply first and then add. But I really need to add this x and y together. Let's assume that I'm creating some kind of exchange rate, or like I'm making a deposit to my account and I want to know what my interest is. Then I can force this by adding parentheses. And just to show you, I will print z here and print z here. So the last two things when our script runs is going to be z, except I'm going to remove these two parentheses. So let's go back. I'm going to clear my terminal, run this again, and you'll notice these two things are different. Now, I use numbers to illustrate that because even though you said you weren't good at math,
Yeah.
but even people who were like, I'm not good at math, they have at least some mathematical intuition. Like, I know there's supposed to be a particular order there. That will extend to other things that we're doing within Python. Excuse me. So I can enforce this order of operation. But you'll notice something about this code. Like, I just did a bunch of stuff. And if I come back to this, I've chosen horrible variable names, right?
Yeah.
Yeah. And how would I know what I was doing? Is there something in Bash where I can notate or?
Yeah, there is actually, and yeah, I see where you're going with this. Justin's got a program here, and it does something. Well, if he emailed me this program and I opened it up and I looked at it, I'd go, okay, it does something. I don't know why it's doing any of this, or like he said, his variables are horribly written out because they're not describing anything very well, or not using that cool syntax that what was it called, snake?
Yeah, snake casing.
Yeah, snake casing. None of that is there, so I have no idea of why the variables are what they are. So I'm going to be at a loss on what's going on inside of this. We tend to use some commenting. And I do this in Bash scripting as well, to let everybody know that it's not me, or even to remind myself, to be honest with you, if I go back a long time later and try to figure out what was I doing with this script, what does this script do, I can look at the comments that I put inside of my script so that I can see, oh yes, it's all reminders, it's all helps to let anybody who's looking at it understand what's happening inside of the code itself. And I assume that any Python or a programming language worth its salt is going to have some sort of commenting feature.
Absolutely, and Python's no different. There's actually two types of comments. So if we look typically at the very top, we want a short description of what's going on within the script. It's like a synopsis. You will see these as what are called triple quotes. This provides me with a multi-line comment. Anything I type between these quotes, I can write paragraphs upon paragraphs upon paragraphs, and this is still a comment, so I don't have to worry about commenting each line. So this is an introduction to basic math, right? So not the best introduction. I didn't say it was a good one, but it is an introduction. If we come back and actually look, you'll notice nothing prints out. That's because the interpreter doesn't see those. It turns a blind eye to them. It's like, you're not there, you're not there. So that's really important, because if I come back later, just adding this simple comment, I'm like, oh, yeah, this is what I'm doing. But what if I'm like, this is a new operator to me. I don't remember what this is. I can actually come back to the end of this line, add a pound sign or the hash, or I think there's another word for octothorpe. I think it's called an octothorpe.
That's exactly right.
Yeah. So, wow.
Good for you.
I'm proud. I can say, this is the modulus operator. Gives remainder. And, you know, my text is zoomed in so everybody can see. This is actually not that long of a line comment. But now when I come back, I'm like, oh yeah, it kind of self-documents your thought process. And what I'll use comments for is before I ever write a really complex script, I'll actually write a bunch of stuff in comments, like the steps that I need to take, and then implement those piecewise. It keeps the problems at bay, things of that.
So it's basically Python is going to, because it's interpreting line by line as it goes through the code, it's going to ignore anything either between triple quotes or a set of triple quotes, so one on top of the other, and anything between that's going to ignore that, and ignore anything after the hash sign or the pound sign, and regardless of where it is.
Right. And this only applies to the line, to the end of the line. Once you hit enter, that is no longer valid. Also, in some other languages, double quotes and single quotes are treated differently. In Python, they're equivalent and actually play in making our lives easier. So I could have all of these be single quotes. Wow, that did some crazy stuff there. I could have these be single quotes, and that still works just the same. And so now this is, you know, this is order of operations demo below. This is the modulus operator. This is the exponent operator. I misspelled exponent.
It's a funny word.
Yeah, it is. It is. It is. It is. So now when I come back to these comments help me self-document what I'm doing, and I don't have to think as much. We need to take these conventions, these variable namings, all of these things are put in place so I can reason about what I want to happen, and Python helps us do that by abstracting away some of all of the ceremony that you'll see in other languages. But comments are very, very helpful in getting that done.
Now, Justin, you were talking before about we're using things like good standard notation, making sure that you have variables that are very descriptive, that we put in comments so we understand what's going on. And all these things are helps to try to keep us from making a mistake inside of our program so that they'll actually run correctly. But as good as we might be, and I know you've never seen errors before in your life, you're that good, but I am not as good as you when it comes to this, and I create errors all the time, and I have to go back in and debug. What kind of basic debugging operations do we have inside, or just using Python in general?
You must have been in my head. You know, I have not seen that many errors. I have to go seek them out. But when they do happen for other people, this is what I hear.
Not you.
Not me.
Yeah. Never.
Wow, I can't even say that with a straight face. You know, let's take the indentation error that we saw earlier. I put a space there. Now, this is a little different than running it in the shell. I don't know that error has occurred. You know, I'm typing away, I'm making this great program that does some pretty groundbreaking stuff. But if I run it, I actually get a similar error that I would on the interpreter shell, except now there's a little extra. It'll say, hey, here's where this error occurred, and these are simple ones that you'll encounter commonly. As these grow in complexity, these error messages will get very long, and you'll go, I gotta go read some stuff. But it also tells you it happened in the file on line 5, and it happened at this point in the file. So if I come back and I'm like, okay, so what's wrong here? It said indentation. Oh yeah, there we go. I found it. It's right there. I messed up the indentation, and now I can come back, rerun it, and my error's fixed. So the Python interpreter will start running your program, but here's the trick. Since this is not a compiled language, but an interpreted language, so like C, C++, C#, Java, they turn all those into code before they're run, and they do a bunch of checks. Like, is this the appropriate data type? Is this formatted appropriately? Before that code runs. Python starts running top to bottom, and it kind of consumes the text as it comes to it top to bottom. So when it came to a problem, it stopped. Now there are ways to mitigate those issues, but our program doesn't run unless it's error-free. That can be a source of deep frustration with people. Not me. Not me.
Yeah.
Not me.
You wouldn't know about that.
Yeah. But I hear people do.
But it's also a source of great help, though, as well, because Now, especially for new programmers, we're not used to seeing errors. We don't know what should be right and what should be wrong. We need that help to let us know, hey, buddy, you threw an indentation there, and I know that you didn't mean to. You never would have done that on purpose. So I want you to go ahead and run back to line 5 and check that out and see if you can't find out where you went wrong and erase the problem. I actually lean on the fact that it will stop and give me some sort of output as to what went wrong, or very heavily, just because I'm not as proficient as someone like yourself, Jeff.
Yeah, I feel like we're propagating a legend that doesn't actually occur. So everybody will have errors. It'll happen to even the best programmers. The important thing is know what to do and what tools are available to you to kind of figure out what those are. So that's one error. And then, you know, what was that other error that we had? We had, oh yeah, we try to do some weird stuff with strings and numbers. So let's say we're trying to assign y, and I'm like, I want 13 apples. And I actually wanted to say 13 apples, but I'm like, I'm going to use a number and a string. So I'm going to put them together, I guess. I'm just trying stuff. And this is something that people will do early on. Let's go run that. And again, we get a similar type error. It says, hey, that happens in variables.py on line 6. And it happens because there is a type error. You cannot add an int and a string together. So I'm like, oh yeah, I forgot about that. So I got to go back. I got to fix that. I got to figure out some other way to do that. So there are ways to do that, and I think now's a good time. Let's use variables to do something kind of interactive, because we're just printing numbers to the screen. I know people are like, well, that's great, but when can we actually use this? So I'm going to create a new file and just say user input.py. And notice that's snake cased. And I'm going to add my shebang, and I have to go look at where my path was. Do you have trouble remembering those also?
Oh, of course. Unless eventually you'll just know where it is, because you use your environment all the time. But yeah, if you're new to the environment, especially if you're new to programming, it's something you're going to have to steal from a lot.
And like, I really like that which, and that'll tell me which interpreter is currently set. Now, when would we use variables? Well, we've stored these numbers, but what if I wanted to interact with a user, right? Like if I had a script that when I typed something back added, it would execute a series of commands or do something kind of simple. Well, in Python 2, there is an input command called raw input that will take user input and spit it back so you can store it in a variable. However, the other side is, in Python 3, that has actually been changed to just input. So there's a little difference there. Since we're using 2, we're going to use the raw input. So if I want user input, that's going to be raw input. And this is a simple command. Whoop, see me? My Java days are coming back. I'm putting semicolons all over the place. So raw input. What is your favorite color? So if I were to run this, oh, wait a minute, we gotta figure it out. There it is. Daniel, this is some. Do you know what's going on? I noticed
It's not red.
It's not. Oh, what did I forget to do, Daniel?
Gotta make these files executable, right? That's what we talked about before. It's not executable. Using it this way is not going to work. You're gonna see what Justin just had right there. Is that it just says, okay, I don't know what you're trying to do here. I'll see if I can help you. And it tried, but it wasn't successful in that, because Justin was trying to get it to do something that it didn't know what it was. So now we have to go back in, make that file executable, so they can actually execute it using standard notation.
So, and just do that with sudo chmod, chmod plus x, and now I can actually take user input. So what is your favorite color, Daniel?
I'm gonna go with blue.
blue. And it actually did that. Well, it didn't seem like it did anything. Let's just have it print out user input. Print user input. And Daniel's favorite color is blue. And so I can now store this user input as a variable, and I can use it later. This is great if I wanted to build command line utilities that made decisions based on those. But that's a little beyond the scope of what we know yet. But we're going to keep that in mind because we're going to make use of that a little later down the road.
Yeah, Justin, you've done a really good job of building a great foundation for us so that we can continue on and create those more complex scripts or programs down the road. Now we are able to work with variables. That wasn't too difficult, right? We're a container that holds a value, and we can do math. We can separate things out using math operands or operators. That's always very helpful. And now we can also debug, comment our scripts, and take user input. And that's going to be really the cool stuff. That's what makes programming fun, is saying, hey, I want to interact with you as the user, and then we'll do something that is unique to your experience. So it's going to be a lot of fun as we get further and further down in that complexity. Justin, thank you for joining us again today and explaining these and building our foundational knowledge of Python so that we can make those more complex scripts. It looks like we have come out of time, though. We thank you for joining us. We thank you guys for watching. We're going to go ahead and sign off for IT Pro TV. I've been your host, Daniel Lowry.
And I'm Justin Dennison.
And we'll see you next time.